Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, December 23rd. Looking at significant wave heights for the North Pacific Ocean, we see remnants of a gale that was off the southern Oregon border, generally produced a short-lived area of 30-foot seas. Swell from that system is starting to impact Northern California now. Also, we see a developing complex low-pressure system near the dateline, seas in the 22-foot range, but nothing too interesting at the moment. Let's dive into the details. As usual, we'll start this week's tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a dip in the jet, sort of like that right here. That dip, of course, creates a counterclockwise flow aloft and also down at the surface. That's the hallmark of low pressure, and low pressure, of course, generates wind. Winds generate seas. When those seas radiate away from the fetch area, they turn into swell. Swell hits your beach. That makes surf. All right, so we see a little tiny trough on the dateline. The only really redeeming quality is that there's 160 knot winds feeding into it. Actually, the jet overall looks pretty good with 180 knot winds pushing off Japan. The jet completely consolidated the whole way pushing into northern Cape Mendocino, Point Arena area with, of course, this area 190 knot winds here, another pocket of 130 knot winds here, and no obvious splits in the jet. So that all looks good. The trough here, yeah, moderate, nothing great. Maybe a little bit of what was a trough here fading out, moving inland. All right, let's put it into motion, see what happens. Yep, the trough builds. Also, another little trough starts developing Monday off of Oregon. Probably not enough to generate swell, but it'll push, maybe make some weather for the Pacific Northwest. See how that goes? Sure enough, look at that. Big, broad, inland low-pressure system likely to result over, Oregon, Pacific Northwest down to California. But also notice when you don't have a trough, when you have a ridge like this, that supports clockwise flow aloft and at the surface. That's the hallmark of high pressure. And what this is likely going to do is set up a bit of northerly winds for the California coast. Meanwhile, on Tuesday, jet looking pretty solid, pushing off Japan. Now notice this, a split develops as we get later into Tuesday, and this is part of the upcoming problem for the eastern half of the Pacific. You're going to get the split jet, you get that, you get high pressure in between the split flow, and that starts creating raking north winds down the California coast. It also drives the storm track up to the north, and that pretty much shuts down California for anything reasonable in terms of surf production or decent surf conditions. We continue on. Split point holds right here about 160 west. Winds start building off Japan on Thursday, though. You get the sense, that something significant is getting ready to happen. This is also, when we get into the MJO section, related to something that's going on in the MJO. There's New Guinea right there, right in this area. Hold that in your mind for when we get there. Anyway, pinched off trough there. Look at the jet building to 200 knots on Friday. That's a strong flow. Here you got your giant ridge holding it off of California. Likely high pressure, north winds, no swell other than wind swell. Whoops, and what was that? It actually went to 210 knots. That's a very strong jet stream flow indeed. The split still in control. 210 knot winds on Saturday, reaching all the way to the dateline and then proceeding east from there on Sunday. And let's just take, how far out can we go? 180 hours, jet stream still at 210 knots from Japan to the, we'll say, the western Gulf of Alaska. At some point, this high, likely associated with the inactive phase of the MJO. The inactive phase of the MJO, we're guessing, is going to be down here. The active phase will be over here. Wherever the active phase is, north of there is where the storm track is good. Here's a classic example of it. Wherever the inactive phase is, north of there, things are bad, and this is a classic example of that. So keep that in your mind. All right, let's move on. Surface level pressure, surface level winds. All right, here we are, 18Z, Sunday. 1028 millibar high off the California coast, driving a light wind flow for the moment. Notice it's ridging inland. Winds basically were dead calm in the Northern California region by evening. A little bit of a north flow earlier. Trades pretty brisk, pushing into Hawaii, but not too far over the top, 15 knots. Weak low pressure on the date line. There's a trough there, right? Makes perfect sense. Put this into motion. Yes, we have a low pressure system developing on the date line Monday with 35 knot winds, maybe getting some traction on the ocean surface. A stronger system with 55 knot winds, so that makes it a storm, but very small behind that on Monday. We'll watch these systems, see what they do. Also notice, remember that steep trough here? Low pressure actually trying to develop off of Northern California Monday night, but notice 1020 millibar high here where the split is getting ready to start to happen. So you get a gradient between low pressure inland, high pressure over here, get north winds. Swell, probably not so much. I mean, yes, you'll get seas, but it's going to be a wind-chopped mess. So kind of right there you go. 30 knot winds, 35 knot winds blowing on the coast Tuesday morning. Not surfable conditions. All right. Anyway, Tuesday morning, 40 knot winds in the Western Gulf. Another system behind that with 50 knot winds. You can kind of just eyeball it here. There's your high pressure. Wednesday, north winds continue. The two systems in the North Pacific fade out. Now here's where the jet starts building. Notice you get this there isn't even a trough forecast in this area in the jet stream, but you get this broad low pressure starting to develop there, contrasted with broad 1032 millibar high here. All this speaks to split in the jet, but also we suspect the active inactive MJO pattern traversing the North Pacific. As we get into Friday, high pressure still hanging on strong, the low stationary but building. Let's keep going as we get into Saturday. Looks like an offshore flow is to develop for California, but look at the size of this low actually circulating this way. There is 30 to 35 knot fetch from Japan nonstop to the date line and even past the date line. That in and of itself, just the amount of fetch, the fetch area, not the speed, but the aerial coverage of it, pretty impressive indeed. And we suspect that's just the beginning of what is going to be a massive storm pattern that is going to develop in the Western Pacific in the weeks ahead. As we get into Sunday, we're almost a week out. You see the picture here. Now winds up to 45 knots, but 30 knot winds still to the date line. That's a steady, nonstop, swell-generating machine. At least that's what it looks like from this perspective. And there's your high pressure, still locked in with, hard to tell whether that's offshore or sideshore winds in California. Anyway, you get the picture. All right, let's go take a look at the wave model charts. So here we go, significant wave heights. Things start to develop. Here's a small system we saw in the Western Gulf on Monday. 24-foot seas, and another one behind it with 28-foot seas building. You'll kind of get the picture. By evening, 40-foot seas in one, let's say 27-foot seas in the other. Certainly both generating swell pushing east. And then seas as we get into Tuesday up to 45 feet in this one, 30 feet in the one ahead of it. You kind of get the idea. Then they both kind of fade out. Remember, we got this split jet stream thing going on here. That'll shear any system that tries to move into it. And that's exactly what happens as we get into Friday. So two swells, but remember, howling north winds. Yeah, find some protected break, something like that. And then once those swells fade, well, then here comes the monster building off of Japan. Not in terms of seas, just in terms of just amazing aerial coverage here. And 20, 22, 24-foot seas over a large area. And that's days of swell right there. Hawaii in the perfect place to catch all of it because they don't have to deal with the north winds that California will. So Hawaii, likely a week out, solid swell on the way. Will be a great start to the new year for Hawaii. Let's take a quick dive into local winds, both for Hawaii and California. Right now, California, other than let's say, Morro Bay, Point Conception area, north winds in control, light winds for Northern California. High pressure, 1028 millibars, driving trades into Hawaii, but nothing particularly unusual about that pattern. But as we get into Monday, this little local low here, watch that. It's going to push in, and that and high pressure starts building. Look at this, how broad of an area it covers. Trades into Hawaii, the north winds by Tuesday morning, 30-knot north winds along the entire California coast, maybe 25-knot into Southern California. Trades light for Hawaii, good deal. As we get into Wednesday, yeah, winds decrease a little bit into California, but not much. High pressure still in control, just locking down the entire eastern half of the North Pacific. Trades light for Hawaii as we get midweek into Thursday. There's your high, 1034 millibar. Split jet stream, just feeding that. North winds in control. You basically can write surfing off in California for the next 5 days. We get into Hawaii now. What's the situation here? A slack wind pattern as we get into Friday. And then finally, Saturday, things wake up for California. It looks like a northeast wind pattern, which is good. But Hawaii, cut off low pressure, north winds, things looking to take a serious dive south in Hawaii. As we get into Sunday, California, yeah, looks like high pressure, north winds, there they come again, not good. And Hawaii, though, out of the issue, out of the problem, winds turning back to light trades. We've got to get this 1038 millibar high for this time of year. That's pretty strong. It's kind of interesting, the diametrically opposed pattern, the strength of the high here and the known strength of the low off the chart in the other direction. All right, let's go take a look at precip real quick for California. All right, so right now, Sunday evening, yeah, there was a little bit of rain over in the Half Moon Bay area, San Francisco area. Very light, spotty showers late this afternoon, this evening. A stronger system, that local low, is supposed to wind up on Monday. By Monday evening, snow starting to develop for the higher elevations of the Sierra. May be a pretty good dump here. Christmas Eve dump, Monday night, and then fading out quickly on Christmas Day. And that's out of the picture. High pressure is the expected next phase of this. And pretty much, it's a little bit maybe showers, snow showers in Tahoe, but nothing significant at all. High pressure takes control, locks everything down. You can see precip going to the north, trying to go to the south, but high pressure just has it locked down. We're out a week into Sunday, and nary a drop of rain expected. Quick look at snowfall potential for the next 10 days is the 10-day GFS, all of it focused on Christmas Eve night, 1 foot of snow. This is for Squaw Valley. Taking a look at snow levels, this is the bottom of the hill here. This is the top of the hill. Yep, snow levels look pretty good. Snow the whole way down to the bottom. Then you see these cold, warm sort of pattern. And wind levels, yeah, 60 knots on occasion. But really, the only area of interest is this Christmas Eve snow system. Brings 1 foot of snow. That'd be good. Good for the mountain. Most of Squaw is open now, so that's good. Can't beat it for Christmas time. This is good news. Quick look at Kirkwood. Basically the exact same picture. Foot of snow. Cycling. Warm, cold, and pretty windy it looks like at elevation. And then Mammoth, not as generous, 4 or 5 inches of snow, and then nothing. The same sort of cycling, but because Mammoth is higher, base elevation like 8,000 feet, for the most part, other than a day or two here or there, they stay cold. We just need precip. We need that high out of the way. Wind, yeah, windy, but what would you expect with that amount of high pressure? All right, so what's driving the pattern? I just don't want to know what the pattern is. I want to know why it is the way it is, right? So that forces us to dig deeper. What's the long-term outlook? Specifically, what's going on with the MJO? The MJO pretty much drives everything, and when it's not driving it, the El Nino Southern Oscillation is driving it. So let's go take a look. And always our first stop on the tour of the MJO is understanding what the winds are doing on the equator. East Pacific here, West Pacific here. That's New Guinea. That is the equator. Date line right there. The arrows are what we're looking at. This from the TAO buoy array, a series of buoys strung across the Pacific. Pretty good way to monitor winds. Now, this isn't winds at this minute. This is 5-day average winds. You can see clearly trades the whole way across the Pacific and the Kelvin wave generation area. This is where what we really look at, one, for generating, of course, Kelvin waves, which are part of the El Nino cycle, but also for monitoring the phase of the MJO right in this area from 70 west, 5 degrees north and south equator, out to about 135 east, 5 degrees north and south. Draw a box right there. If the winds are calm or westerly in this area, that's good. If they're easterly, that tends to mean the inactive phase of the MJO. The inactive phase of the MJO tends to steal energy from the jet stream. So right now, we're saying, wow, probably inactive phase given this wind situation. Look at anomalies, differences from normal for this time of year. It's normal to have east trades in this part of the Pacific, but over here in the Kelvin wave generation area, these are stronger than normal. All this clearly smells of the inactive phase of the MJO. All right, but we do know that the jet stream at this very moment is doing pretty good. So how do you resolve that dilemma? Well, what you say is, we got something that almost smells like El Nino feeding the jet stream, and then the MJO is sort of overlaid on top of that. At this moment, it appears that the El Nino pattern is stronger than the MJO pattern. Something to consider. What have winds been doing in the Kelvin wave generation area for the past 5 days? Okay, let's take a look. Here's the equator, 0, right down the middle of the chart. South America, Mexico, Australia, New Guinea, Kelvin wave generation area. Draw a box in your mind right around in there. Look at this. Easterly anomalies in the eastern half of the Kelvin wave generation area. Westerly anomalies in the western half. Sort of in a dividing line right here. Sort of like active phase over here, inactive phase over here. All right, so that was December 17th. 18th, same deal. The 19th of December, same deal. 20th, the same deal. The 21st, the same deal. So it's like the MJO, we think, is kind of like stalled. It's just hanging here over the maritime continent, where the inactive phase is over here in, I'll call it, just east of the date line. And let's go take a look at the forecast. So here we go, the whole planet on one chart, the date line running right up the middle, Kelvin wave generation area between these two tick marks. So in the past, here's what we get. We go down here, we see December, we see blue, that's easterly anomalies in the Kelvin wave generation area. So that would probably be associated in a pretty good long stretch for multiple 2 weeks, 2.5 weeks, meaning the inactive phase of the MJO, and it moves from west to east. So you see, yeah, you have some westerly anomalies here, but then you see, as we got into mid-December and later December, strong easterly anomalies over the date line, and the forecast is for them to continue, but you can pretty much draw a line in your mind's eye going right down like this, and that is just a sign of the inactive phase moving across the Pacific from west to east. But what do we also see? Well, so over here, this is in the Indian Ocean, we see westerly anomalies in the Indian Ocean moving to the maritime continent and building over the next week by the, December 30th. Very strong westerly anomalies just about poised to enter the Pacific. And remember the jet stream charts? Remember how the jet just starts building to 210 knot winds right in the far west Pacific and then moving across the Pacific over the next week, all attributable, we think, to the building active phase of the MJO in the West Pacific. And let's be clear, this is a pretty significant event, we think, in that in terms of surf production initially, probably pretty high the whole way through the month of January. And at some point, the active phase of the MJO, California's at 120 west. At some point when the active phase moves south of California, that's when rain and snow event will happen for California as well. All right, let's go look at some other models. Outgoing long-wave radiation, just another way of looking at the MJO. Where the MJO is, right here, the blue, negative anomalies, that means less sunlight reflectivity off the ocean's surface. That means clouds, that means low pressure. That's the active phase. Inactive phase, hey, just about where we thought it would be. just from the date line and east there. So it's in the East Pacific. And we know high pressure building north off California of the inactive phase, low pressure building off of Japan north of the active phase. So it all makes perfect sense. And the forecast for the next 2 weeks, well, you see here is the active phase, bump, 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 moving right in the center of the Kelvin wave generation area 2 weeks out, while the inactive phase, per the statistical model, pretty much disappears and is gone. All right, let's go see what the dynamic model says. Now, it's not as aggressive about how quickly the active phase is going to move east. And in some ways, that's good. The longer it hangs here, the more it feeds the jet stream, the more it, produces storm. If it's a slow-moving active phase, that's good. That just means there'll be more opportunity for storm production over the next 2 weeks. But anyway, so the GEFS moving a little bit slower than the statistical model. Phase diagram charts, yet another way of looking at what the MJO is doing and what it's supposed to do. Assume you're looking down on the North Pole here. The MJO, both active and inactive phase, move from west to east, from the Indian Ocean over the maritime continent, across the West Pacific over the dateline, under the United States, across the Atlantic, across North Africa, back to the Indian Ocean. Where the heavy dot is where the active phase is right now. No big surprise over the maritime continent, like Bali, let's say. The further the dot is away from this circle, the further out this way it is, the stronger it is. So a pretty healthy active phase of the MJO over the maritime continent. The ECMF model predicts it will get weaker while it moves into the West Pacific. The GEFS model says it will hold strength, but then sort of stall in the far West Pacific 2 weeks out. So a little bit of a disparity. One says it races east and weakens. The other says it holds strength, but doesn't move as quick, which is kind of what we saw in the statistical versus the dynamic models in the previous slide. Upper level model paints pretty much a similar picture. So where the greens is, those are areas favorable for precipitation. Where the yellows are, that's unfavorable for precipitation in the upper atmosphere. So the active phase, it looks like, building in the West Pacific, supposed to traverse the Pacific and be into Central America on January 17th. That seems awfully quick, followed by the inactive phase of the MJO pushing into the West Pacific, January 12th, and then making it into South America on February 1st, followed by another active phase. This model has been an outlier in that it seems way too aggressive in terms of the speed of any MJO activity traversing the Pacific. And then we look at the CFS 850 millibar wind charts. Same deal, used for monitoring at the MJO. So December 22nd, here we are. This is the same deal. Whole planet on one chart, date line running right up the middle. And where you see reds and oranges, those are westerly anomalies. So right now, see this dotted line? That's the inactive phase of the MJO, and it suggests the inactive phase of the MJO is dying as of today. And you see easterly anomalies on the date line right here. In another day or two, they're supposed to be gone. And what do we see replacing them? The solid contour is the active phase of the MJO, building in the far West Pacific, let's say 5 days out, with strong westerly anomalies building and continuing to traverse the, not even just right into the middle of the Kelvin wave generation area on January 19th, and likely going past that. This suggests a good long run of winds that will feed the jet stream, feed storm development, and the models are picking up on that. All right, let's go take a look 3 months out. All right, so here's the long-run CFS model. Now things are reversed again. Kelvin wave generation area between these two tick marks, but past performance is down here. The forecast is looking forward. So today, what do we have? Yep, easterly anomalies on the date line, and they're supposed to last, maybe another day or two? While westerly anomalies are building, they're over the maritime continent. They're not even in the Pacific Ocean yet. You see the picture here. As we get into January 1st or so, strong westerly anomalies. These are westerly wind burst level westerly anomalies continuing nonstop from January 1 to the end of February and in the core of the Kelvin wave generation area. most impressive. Let's overlay the MJO, and you see why. Strong active phase. The solid contour is the active phase of the MJO. So here's our inactive phase moving out of the Kelvin wave generation area and gone, 3 days from now it's gone. By Christmas it's pretty much gone. Strong active phase building in the West Pacific, continuing into February, and even after it's gone and the inactive phase sets up, westerly anomalies continue. So if you were to put a big fat X over this entire stretch and say, is this a good time for storm production and swell production in the Pacific? The answer is unequivocally yes. But after that, then the inactive phase, followed, of course, by the active phase in March. Now, what's the deal here? Notice the strength of the active and inactive phases prior to that and then moving forward. Well, supposedly El Nino was developing. Supposedly it was stomping on the MJO, and that's pretty typical. The MJO is weak. But now it looks like maybe El Nino will be fading. The MJO will wake up and sort of pick up the slack. And maybe that's just a seasonal thing. We don't know. We just have to see how this plays out. But it's a guess that maybe that's where we're headed. And then we look at the low-pass filter. Well, the low-pass filter says, okay, this is sort of gives you an idea of the strength of El Nino. You see, look at this. 1, 2, there were 3 contour lines, and it just died, that third contour line, suggesting that El Nino is weakening in the past 5 days, and it's supposed to stay weak till we get into February 1st, and then resume, and actually almost looks like it backtracks a little bit. Hard to say. So California is at 120 west, so basically this El Nino signal to fill the entire Pacific while you have, so this is a low pressure bias. The dotted contour would be a high pressure bias. So La Nina building in the Indian Ocean. None of this is a surprise. We've been talking about it for weeks. It's going to be interesting to see whether this third contour line returns, because if it does, it holds for any length of time, like into May or June, maybe that's a sign that, yeah, this was a false start El Nino. Sort of all it did was snuff out La Nina in the Pacific, and maybe our El Nino isn't going to come till next year, or maybe even the year after that. But when you get this kind of low-pressure bias over the central Pacific like this is good for storm production and surf production. All right, what's going on in the ocean? Water temperatures. East Pacific here, West Pacific here. We're looking at depth. We're on the equator, 2 degrees north and south of the equator. The X's are the sensors on the TAO array buoy anchor lines. Okay, and that's how you get the data. And then you use a model to sort of fill in the gaps. What do we have? 30 degrees Celsius water temperature, warm water in the West Pacific. The 28-degree isotherm. At 160, it had pushed over to about 153 a couple weeks ago. It's retrograding, suggesting that your El Nino Kelvin wave cycle thing is sort of backtracking. The 24-degree isotherm line still pushing into Ecuador, though, suggesting that warm temperatures to some degree are migrating east, but not strongly so. Let's look at differences from normal for this time of year. Well, we see obviously warm water, 3 degrees Celsius, almost 4, above normal in the central Pacific, down about 150 meters. That sure looks like a Kelvin wave to me. It originated over here a couple weeks ago. It's been moving off to the east, moving to the east, and it's continuing to east. There was Kelvin wave number 2 impacting Ecuador. It's all but gone. Still, a broad pool of 2-degree anomalies filling the entire subsurface Pacific. That's good news. No cool waters to be seen. La Nina, gone, gone, gone. El Nino trying to develop. Not sure that we're there yet. What we really need to see, and I think we're going to see it, is a bunch of westerly anomalies building as the active phase of the MJO sets up. That will probably start another Kelvin wave. If this is Kelvin wave number 3, and that's a kind of a big if because this is a pretty weak-looking Kelvin wave, then Kelvin wave number 4 would be behind it. Other data, say a different model, same data, modeled differently. You can see, yeah, maybe there's warmer than what the previous chart showed, pushing into Ecuador. Here's the Cora Kelvin wave number 3 with, what is that? 1, 2, 3, 4, 5. 1, 2, 3, 4. 4-degree anomalies over a tiny little dot right there just east of the date line. But still, pretty warm signal. We need to see more warm water building here. You take a look at sea level anomalies, so things have kind of weakened here. This is JSON-2 satellite data. Strip out all the waves, strip out all the wind swell, strip out the tides, and you see that there's a 5-centimeter bump on the ocean across the equator, 0 to 5 centimeters. It was actually a stronger signal, 5 centimeters nonstop the whole way back to here. There's a little bit of a gap here today, suggesting not as much warm water at depth. So warm water, of course, expands a little and expands down 150 meters. It creates a little bump on the ocean surface. That's what this chart is trying to confirm. Well, is there warm water and what's the expanse of it? Well, yeah, here. And it basically makes sense with everything else we saw. So warm water also seeping out of the maritime continent, right in this area, pushing into the equatorial region. If we got more westerly winds here, maybe that might bump some of these numbers up here. And yet one more view here, upper ocean heat anomalies. So this is the West Pacific here, this is the East Pacific here, last year this time. The oranges, yellows, warm anomalies, blues, cool anomalies. La Nina, in effect, and the hallmark of La Nina is cold water in the East Pacific on the equator, and warm water balled up in the West Pacific. A little tiny Kelvin wave made it across January a year ago. It died, but it basically cut off La Nina, and La Nina was gone. As we got into February, here we go. Westerly anomalies started pushing warm water from the maritime continent out across the equator. That Kelvin wave, that's what it is. It's called a Kelvin wave. Finally, it took forever, but finally moved onshore over in Ecuador in July. And then Kelvin wave number 2, very strong westerly wind burst in the September timeframe. It's made its trek across. And now Kelvin wave number 3, didn't really see much of the signal here. You see a little sign of it right there. That's today. And theoretically, it's to move east, but it's pretty weak, and it's almost obscured or completely buried in lingering remnants of Kelvin wave number 2. All right, so what's going on at the ocean surface? Right, so there's New Guinea there. There's the maritime continent. We see warmer than normal water in areas here. We see, but moving into the Pacific on the equator, there's warm water building on the date line. And then here's the main thing we've been looking at. This signal of warmer than normal water, not super warm, but a little bit, along the equatorial Pacific. A little bit of cool water there showing up off of Ecuador. Warm water this week has built off of Peru. That's kind of an El Nino sign. This whole thing here is an El Nino sign. But the real issue is how really warm are those waters? And then part 2 is, once they're there and they've been there a while, has the atmosphere started to respond? If you have warm water here, that creates evaporation. If you have evaporation, that creates rainfall. That feeds energy into the jet stream. That feeds energy into the upper atmosphere, and that builds the storm track and pushes it towards California. What's the sea surface temperature trend the past 7 days? Well, we see that clearly. Building warm water off of Peru. That's a good sign. And continuing along the equator. Not markedly so, but certainly building. Down in these areas, it's really what's going on in what they call the Nino 1.2 region, which is right here off of Ecuador and Peru, right along there, the Galapagos. Then Nino 3.4 from 120 west to 170 west, 5 degrees north and south of the equator. That's where you really get your El Nino signal, and that's what affects the jet stream. Right now, yeah, waters are warming, but not markedly so. The overview picture, of course, warmer than normal water on the equator the whole way across the Pacific. Is it enough to be El Nino? Yeah, maybe, maybe not. And it's not just the warm temperatures. Is the atmosphere responding as well? Maybe, maybe not. We're going to find out in a second. But we have what appears to be a somewhat El Nino-like pattern. Clearly not La Nina, and that's good enough for us. Temperatures in the Nino 1.2 region, right there by Ecuador, Peru, the Galapagos, falling today, down at 6.673 of a degree above normal. It was a little bit higher, up around 1 degree, but that's not the official El Nino monitoring region. But this is an area where Kelvin waves tend to erupt, And so you can sort of see what Kelvin wave activity has been doing over the past 2 or 3 months here. And yeah, things have been warmer, not cooler, so it's certainly not La Nina. In the official El Nino monitoring region, Nino 3.4, temperatures today, 0.641 above normal. Yeah, they were up to 1 degree there for a couple of days, but really, if you take this whole trend line here, yeah, and they were up to 1.5 degrees for 2 or 3 days somewhere else, but in general, the trend looks kind of stable at about 6.65 degrees above normal. Has to do that for 5 months in a row to officially be declared El Nino, and it only started the end of September. So October, November, and December have been warm. We got 2 more months to go before you can even declare El Nino, just based on temperatures alone. But to have El Nino is more than sea surface temperatures. You also must have an atmospheric response. That is, the atmosphere must be responding to the changes in the surface temperatures in the equatorial Pacific, and the upper air circulation pattern over the entire planet has to change in response to those warming temperatures. So, you have the Southern Oscillation Index, one way of measuring that atmospheric response. Difference in pressure between Darwin, Australia, and Tahiti. Okay, so we'll take a look at the numbers here. The daily contribution, positive 5.66. If it was El Nino, pressure would be lower in Tahiti, and this value would be negative. In fact, looking back the past month, nary a 1 or 2 values, everything else is positive, meaning literally no El Nino signal in the atmosphere, according to this. The 30-day average strips out the noise, and what do you get? Well, a month ago we were at 0.5, a lot closer to being negative than we are today. This looks, at a minimum, like the inactive phase of the MJO at 9.41, and if it persists long enough, 90-day average, the 90-day average is 3.34. So I'd say this is an inactive phase signal affecting this index. We're basically neutral. This guy would need to be up at like 10 or 15 to be the inactive phase. Likewise, it need to be down at minus 15 to be an El Nino signal. But you can see clearly we've gone from negative a month ago to positive today. So certainly no El Nino signal here. And you can see the 30-day average value. So here we were, January 2016. Big El Nino. We were negative. See the spikes here. The downward spikes are the active phase of the MJO. Then a massive inactive phase. And as we got into fall of 2016, we were in a weak La Nina pattern. Most values positive. Continued through 2017 and 2018 until about July. Then we went neutral. Here we are today, going back positive. It's kind of not encouraging in a way, but maybe that's not so bad. The other atmospheric indicator or indice, the ESPI index, instead of pressure, it's all about precipitation. If you have more precipitation in this area here in the Pacific and less precipitation over the maritime continent, then you have a positive value, meaning more rainfall here, and that would tend to be supported by warmer than normal water temperatures at the ocean surface here. But today we're at 0.09, basically dead neutral. No signs of El Nino in the atmosphere either. Interesting. And the sea surface temperature forecast for the CFS model? Well, here we are here. The model says temperatures should be 0.95 degrees above normal. They're not. They're 0.6, so we're really down here somewhere. So this model is grossly overstating what's going on. And they continue to suggest that temperatures will build to 1.4 degrees above normal. Completely unbelievable given what we're seeing, on everything. Yes, this building active phase of the MJO could possibly produce a Kelvin wave, and that Kelvin wave could push more warm water to the east, but my guess is it'll keep temperatures about where they are right now, somewhere down around this range, because you remember looking at the subsurface temperature charts, Temperatures, yeah, there's a Kelvin wave out there. It's pretty weak, and it's moving east fast and fading. And another Kelvin wave, if it develops in January, won't even get here till 3 months later. It won't even get to Ecuador 3 months later. Then there's another month after that to get in the Nino 3.4 region, so we're 4 months out. So this is complete fantasy land in our estimation. But the point being, that's still not bad. Temperatures are warm. They're not cold. If they're cold in the East Pacific, that builds high pressure, and that just does nothing for the jet stream. This is not a bad pattern, especially if it continues for a year or two, like we've been talking about. We don't see any indication that that won't happen, given where we are now. So to put a bow on our gift and stick it under the Christmas tree, we're saying, yes, it looks like there's some small swells on the way for the coming week. A lot of wind for California, and those swells will bypass Hawaii for the most part, but give it about a week. I think we're talking a whole different picture. Santa Claus will come a little bit later than what we would like, but you know what? Looks like the North Pacific is going to be open for business big time in a week from now, and it probably won't stop for at least a month, if not 2 months after that. So, enjoy the downtime while you can. Spend time with friends and family and have some fun. And then we're going to get into some serious surf and maybe precipitation and snow business as we get about midway into January. So that's it for this week. We think we're going to do this again next week, same time, same channel. We'll just see how things go, trying to take a little downtime for the holidays. Everyone, enjoy yourselves. Have a good time. Hang out with friends, family, and Merry Christmas, Happy New Year. But we think we'll do this next Sunday. That's it for this week. See you again. Bye-bye.